let's take up the next question. Show that the 4 points in the Argand plane represented by the complex numbers 2 plus I, 4 plus 3I, 2 plus 5I, 3I are vertices of a square. So now see, this is a square. In a square, all sides are equal and diagonals are also equal. So first, let us write the complex numbers in the form of coordinates. So what are the given points? We can directly convert the complex numbers into points. They are A 2, 1, B 4, 3, C 2, 5, D 0, 3. Now we will find out AB first. We'll find all the sides. We use distance formula. What is distance formula? X2 minus x1 whole square plus y2 minus y1 whole square. So 4 minus 2 whole square plus 3 minus 1 whole square. So that is root over 2 square plus 2 square. That is root 8. This is AB. After finding AB, we will find BC. BC is root over 2 minus 4 whole square plus 5 minus 3 whole square. That is root over minus 2 whole square plus 2 square. That is again 4 plus 4, which is equal to root 8. Now the same way we will find CD. CD is root over 0 minus 2 whole square plus 3 minus 5 whole square. So that is root 4 plus 4. This is also root 8. Now you can see after CD we will find out DA. So DA is root over 2 minus 0 whole square plus 1 minus 3 whole square. So that is root 4 plus 4, which is equal to root 8. Now we found all the sides and we got it as root 8 itself. So AB is equal to BC is equal to CD is equal to DA, which is equal to root 8. So we got all sides are equal. Okay, now after we get all sides are equal, we will find out the diagonals. What are the diagonals? AC and BD. So first let's find out AC. AC is 2 minus 2 whole square plus 1 minus 5 whole square. That is root 0 plus minus 4 whole square is 16. That is root 16 is 4. Now we will find BD. BD is 4 minus 0 whole square plus 3 minus 3 whole square. So that is root over 16 plus 0, which is equal to 4. Okay, so AC is equal to BD you got. Now since AB is equal to BC is equal to CD is equal to DA. These are the sides, which means all the sides are equal. And AC is equal to BD, which means diagonals are also equal. Then we can say that it forms a square. Now you can see this is the next question. So 4 complex numbers are given to you. Let us convert them into coordinates. So first we will write given points. Given points are minus 2, 7, minus 3 by 2, 1 by 2, 4, minus 3, 7 by 2, 7 by 2. If I multiply this into this, real part is 7 by 2 and imaginary part is also 7 by 2. So we got 4 points. Let us name them A, B, C and D. Now, as usual, how we found A, B, B, C, C, D, D, A in the last problem, we will do the same. So AB is, now here you have fractions, so you need to do it carefully. So x2 minus x1 minus 3 by 2 plus 2 whole square plus 1 by 2 minus 7 whole square. Now you take the LCM here in the bracket. So you will get minus 3 plus 4. We cross multiply by 2 whole square plus. Again we take the LCM within the bracket. So 1 minus 14 by 2 whole square, which is equal to root over 1 by 2 whole square plus minus 13 by 2 whole square. So that is root over 1 by 4 plus 169 by 4, which is equal to root 170 by 2. This is AB. The same way we find BC. BC is root over 4 plus 3 by 2 whole square plus minus 3 minus 1 by 2 whole square, which is equal to root over 8 plus 3 by 2 whole square plus minus 6 minus 1 by 2 whole square. 8 plus 3 is 11. 11 by 2 whole square is 121 by 4. Minus 6 minus 1 is minus 7. Minus 7 by 2 whole square is 49 by 4. This is also root 170 by 2. Now we'll see how to find CD. CD is root over 4 minus 7 by 2 whole square plus minus 3 minus 7 by 2 whole square. So that is root over. Now you need to cross multiply. 2 4s are 8. 8 minus is 1 by 2 whole square plus minus 3 into 2 is minus 6. Minus 6 minus 7 is minus 13 by 2 whole square. So that is equal to root over 1 by 4 plus 169 by 4. This is again coming out to be root 170 by 2. Now we will find out dA. dA is distance between D and A. Again we use distance formula. Minus 2 minus 7 by 2 whole square plus 7 minus 7 by 2 whole square. That is root over. Again you cross multiply. 2 into minus 2 is minus 4. Minus 4 minus 7 is minus 11 by 2 whole square plus 2 sevens are 14. 14 minus 7 is 7 by 2 whole square. So that is root over 121 by 4 plus 49 by 4. This is again root 170 by 2. So what did you conclude here? AB is equal to BC is equal to CD is equal to DA. Now we need to find out AC and BD. Like we need to check the diagonals, whether they are equal or not. If diagonals are equal, it forms a square. If diagonals are unequal, it forms a rhombus. But for square and rhombus, both sides are equal. All the four sides are equal. So AC is root over minus 2 minus 4 whole square plus 7 plus 3 whole square. That is equal to root over minus 6 whole square plus 10 square. That is 36 plus 100, which is equal to 136. You got AC value. Now we need to find out BD. So again, we apply distance formula minus 3 by 2 minus 7 by 2 whole square plus 1 by 2 minus 7 by 2 whole square. That is root over minus 10 by 2 whole square plus minus 6 by 2 whole square. So that is root over minus 5 square plus minus 3 square. That is root 25 plus 9, which is equal to root 34. So you got AC as root 136 and BD as root 34, which is not equal. AC is not equal to BD, which means diagonals are unequal. And sides are equal. AB is equal to BC is equal to CD is equal to DA we got. That means sides are equal and diagonals are unequal. Therefore, it forms a rhombus. Now take this question. This is also very, very important. Show that Z1 is equal to 2 plus 11i by 25. Z2 is equal to minus 2 plus I by 1 minus 2i whole square are conjugate to each other. So what do we have to show? That these two complex numbers are conjugate to each other. Conjugate means if one is a plus ib, the other will be a minus ib. So first one is already in a plus ib form. So let us solve the second complex numbers. Okay. So first we will write both the complex numbers. Given z1 is equal to 2 plus 11i by 25 and z2 is equal to minus 2 plus I by 1 minus 2i whole square. So first we will take z2 and we will solve it. So minus 2 plus I by 1 minus 2i whole square. Now open the brackets. Minus 2 plus I by denominator we will open. A minus b whole square. A square plus b square minus 2ab. Okay, so that is minus 2 plus I by 1. I square is minus 1. So 4i square will be minus 4. Minus 4i. That is equal to minus 2 plus I by minus 3 minus 4i. Now we rationalize the denominator. So we get minus 3 plus 4i by minus 3 plus 4i. Now these two brackets we multiply in the denominator. So how do we multiply it? This into this, this into this, this into this, this into this. So you get minus 2 into minus 3 is 6. Minus 2 into 4i is minus 8i. I into minus 3 is minus 3i. I into 4i is plus 4i square. By a plus b into a minus b is a square minus b square. So minus 3 whole square is 9. Minus 4i whole square is 16i square. So 6, we can add these two. Both are negative. We add and keep minus sign. So this is minus 11i. 4i square is minus 4 by 9 plus 16. So that is equal to 2 minus 11i by 25. This is Z2. But can you see this is the conjugate of Z1? Z1 is 2 plus 11i by 25. Here you got 2 minus 11i by 25. So this is nothing but conjugate of Z1. So we got it as Z1 bar.